Awesome, perfect. All right, well, thank you so much again, Dr. Collins, for coming to see us and give this talk for Science in the Bible Club. Just a little information on Robin Collins. He is a distinguished professor of philosophy at Messiah University in Pennsylvania. He has written many, many articles and book chapters in philosophy regarding areas of philosophy such as quantum mechanics, science, and religion. And most recently, Dr. Collins has been finishing a project on fine-tunings of the universe and our ability to do science, funded by the John Templeton Foundation, which is pretty cool. So thank you so much, Dr. Collins, again, for being here today and to give this talk for SciBle.
Okay, are we ready to go?
Ready to go.
Okay, so first of all, I just want to say something about how big and vast the universe is. See this picture here that's behind me where I've transported myself? You might think that's among the stars. Well, actually, all these little dots are galaxies. This is Hubble Deep Field View, and it's only if you stretch your arm out and had a pinhead, that's the size of the sky it is. And each of these galaxies, on average, a galaxy contains about 300 billion stars. And there's approximately 300 billion galaxies in just the observable universe, and it's probably much larger than what we can observe. So the universe is a really, really vast place. And so keep that as and I think it demonstrates the, as Paul talks about in Romans 1, the power and eternality of God. It's kind of imprinted on the universe, God's vastness, and the age of the universe being very old, about 13.8 billion years, gives you a sense of also God's eternality. So it's printed just on the basic features of the universe, something the Apostle Paul wouldn't have known at the time. So let's now go to this my slideshow. And my talk is, I call it the fine-tuning design argument. It's an argument from physics and cosmology for the divine creation of the cosmos. Let's see, why am I not, okay. Okay, there we go. I was just, my thing my computer wasn't working on me. So the big issue is the issue of science and God. Many people think that modern science undercuts belief in God, but I will argue that just the opposite is the case, particularly in the last 50 years or so, that what we have found out from physics and cosmology strongly supports divine creation. So I will be offering what's called a design argument. It's one of the oldest arguments and most common argument for the existence of God, both in the East and the West. So it occurred in ancient India as an argument for the existence of God, among the Stoics in ancient Greece, and Thomas Aquinas articulates it. And then more recently, in 1802 was William Paley's design argument based on the apparent design of plants and animals, which he compared to a watch. And that really impressed people so much that everyone who graduated from Cambridge University had to study this argument, including Charles Darwin. But many people, and this is controversial, think that Darwinian evolution undercut this argument. But even if you think Darwinian evolution undercut this argument, by about 50 years ago, people started discovering another sort of design in the universe at a much deeper level, so deep that not even evolution could take place unless the universe were designed in this way or had this fine-tuned structure. So what they discovered is that the universe is analogous to a biosphere. Its basic structure must be precisely set for life to exist. This is called the fine-tuning of the cosmos. Can everybody hear me and see me okay? Okay, everything's okay? Kathleen and Thomas, am I frozen or something? Hello? Can you hear me?
You're back.
Okay, I'm back. Okay. Let me know if I'm not back so I can stop. I don't know whose connection it is. My internet connection seems to be okay. Okay, so the key assumption behind this argument is that the relevant kind of life is what I call, that's fine-tuned for, is what I call embodied conscious agents. And that such agents, like ourselves, require stable, reproducible complexity. So there's three types of fine-tuning for life. There's one, the fine-tuning of the laws of nature. Another is the fine-tuning of what are called the constants of physics. A third is the fine-tuning of the initial distribution of mass energy of the universe at the time of the Big Bang. To say that the laws are fine-tuned means that the universe must have precisely the right set of laws for highly complex life to exist. And I will consider 5 of around 14 examples. So the first law is that of universal attractive force, which we call gravity. So what we can do is we can do these thought experiments. What if that law was missing? Can you hear me okay still? Put your thumbs up, that's good enough. Okay. So we could just imagine, what if there were no gravity? Well, the first thing there would be is no stars, because stars are very hot and hot gases expand. So what keeps a star together and allows it to produce energy is the force of gravity. And if there weren't any stars, then there wouldn't be any life, because stars, they serve as an energy source. And the energy from stars is effectively produces what they call negative entropy, which is a source of order. So without that constant source of order, things by the second law of thermodynamics go from order to disorder. An example of that is your dorm room or your apartment room. If you're not constantly putting it back in order, it turns into a huge mess. So likewise, we need stars for that reason. But further, gravity is essential for having places that life like us could evolve or exist on. What we call planets. If there were no gravity, there would just be a uniform distribution of mass in the universe. Another example is the existence of the electromagnetic force. It refers to a combination of the electric forces and magnetic forces. And a physicist called James Clerk Maxwell unified the two forces in the late 1800s. I consider this one of the greatest scientific discoveries of all time. The reason is that gave rise to this huge increase in technology we saw from around 1900 to where we are now. Electric motors, cars, radio, all that stuff is based on what James Clerk Maxwell did in unifying those two forces. Now, what if there were no electromagnetic force? Then there'd be no atoms and therefore no life. There'd be nothing to hold the basic particles of electrons, protons, electrons in orbit around the protons and neutrons. So there'd be no chemical bonding, and so there'd be no building blocks of life.
Frozen again.
Okay, should I just wait? How is your internet connection there? Let me know when I unfreeze. I'm unfrozen now?
You're back.
Okay. So there'd be no chemical bonding and therefore no life without the electromagnetic force. Let me just quickly, I'm going to go off screen share. Oh, there I see my internet. I went off screen share. I just want to make sure my internet connection seems really strong, so I don't think it's here. Okay, I'm going to go back on to where I was. Okay. So if there weren't any electromagnetic force, there wouldn't be any light and also no life, because light is an electromagnetic wave. That means that what happens is electrons jiggle back and forth. You could think of it that way. And they produce a varying electric field. A varying electric field produces a varying magnetic field, which creates what they call an electromagnetic wave, which propagates at the speed of light. So it's the existence of both the electric and magnetic field and how they interact with each other that allows light to get from the sun to the earth and to allow for life to exist. What's interesting, if you look at the universe, is that often it's also constructed in a very elegant way. So
Robin,
yeah,
we're going to try switching from my computer to Katie's.
okay.
On the hope that that might help us. So bear with us for a moment. So.
I could just also check to make sure my computer, it isn't like there's something gobbling up a lot of its. No, it's not. It's got normal.
Okay, we're running through Katie's now. We'll see if that is better.
Okay, can you hear me okay now?
We can.
Okay. So often the universe is constructed in a very elegant way. So the electromagnetic force not only serves the function of the electrons being held around the nucleus in atoms, but serves the purpose of transmitting the energy from the stars to the earth, but serves also another really important purpose. And that there's this kind of fine tuning for scientific discovery, which I won't focus on today, but I'll mention a little bit more, that the universe also appears set just right so that we can discover it in an optimal way. And the electromagnetic force is what's behind radio waves, TV, and the working of your cell phone. In your cell phone, little electrons are going back and forth very rapidly, about over 1 billion times a second, and they produce electromagnetic waves. In the case of light, it's in the 100 trillion times a second. Blue light is about 700 trillion times a second is how fast the thing's going back and forth, the electric and magnetic field. Okay. So we looked at one thing required is the atom. So now I'm going to focus more on the building blocks of life. Just some of the laws required to have basic building blocks, which, as we know, are molecules that then bind together. So have you ever wondered what holds the nucleus together? After all, protons are positively charged and like charges repel each other. That's what we learn in elementary school. So why does the universe nucleus just fly apart? Well, the answer is the strong nuclear force. This is before I went into philosophy and when I ran for governor of California. So something has to hold the protons together, and it's this strong nuclear force. And this is actually an appropriate picture for that because the strong nuclear force has to be short range. In other words, it can't reach out very far. Like gravity reaches out really far from the sun to the earth, and so does electromagnetism, reaches out way out to the electrons, for instance. But the strong nuclear force has to be really strong to overcome the repulsion, but can't have very long arms, so to speak. Because if it did, it would reach out to the nuclei of other atoms and pull them together, and then you wouldn't get separate atoms, you'd get just one huge conglomeration or a black hole. So you wouldn't get life. So it has to have a special form. Now, so you have the strong nuclear, you have the nucleus and the electrons going around, and you might think you're done in building an atom. You would be wrong if you thought you were done. The problem is, we know from the Maxwell's theory of electromagnetic radiation that an electron going around a nucleus, it's accelerating, should emit radiation. So very quickly, on the order, less than a millionth of a second, it would collide into the nucleus and it would all be over. There wouldn't be any atoms, no life. So there has to be another law to keep that from happening. Well, this is the law of quantization, or the principle of quantization, first articulated by Niels Bohr in 1913 after the atom was proposed about a decade earlier. So it dictates that the electrons occupy fixed orbitals. This keeps them from being sucked into the nucleus. Otherwise, it all just collide with the nucleus. So you might think you were done. Okay, we've got our atom. Once again, you would be wrong. The problem is, one of the problems, there's another problem too, is that all the atoms, if this were just right, well, if they just had to be in fixed orbitals, then all the atoms being sucked by the nucleus would just go to the first orbital, fall into the first orbital. And if that was the case, there'd be no complex chemistry, so there wouldn't be any molecules. Further, if that was the case, there wasn't something additional. It was proved in the 1960s that all matter would collapse in on itself within less than a microsecond. So you wouldn't have anything hard. When you have any liquid, it'd all be over. So what does the trick? Well, this is what we have. The solution is the Pauli exclusion principle. That requires that no more than 2 electrons can occupy any orbital. So that keeps this from happening. And as I said, it also allows for there to be solid matter. Now, when I first realized that, and this happened various times when I was working on this project years ago for this part of the fine tuning, I realized how miraculous the universe is. I mean, when I'd walk across like a floor, that I was able to stand on a hard surface was truly amazing, because this is just a principle. Although there is a deeper explanation for it in quantum mechanics, that is just another principle, and there's no reason why that principle should hold. So it's like, why does that principle keep acting? There's no material explanation for it. It just does. And that seems really miraculous. No, I think it's upheld by God. So the very solidity of matter, as you might have heard, most matter, is most atoms, most of it is empty space. There's about 10 trillion times as much empty space as there is solid matter. So it's this Pauli exclusion principle that allows any surface to be hard, to feel hard, even though it's mostly empty. So that's another way of a single principle, not only allowing for complex chemistry, but it also allows for the existence of matter, period. So in summary, I've just went through some examples: gravity, electromagnetism, the strong nuclear force, principle of quantization, the Pauli exclusion principle. If one of these laws were missing, you wouldn't have any life. And that's about five, 1, 2, 3, that's 5 of about 14 examples you could articulate. So I left out quite a few. So that's the fine tuning of the laws for the existence of life. But there's another kind of fine tuning, and this probably has been the most discussed because it's quantitative, and that's the fine tuning of the constants of physics. The constants of physics are just numbers that occur in the fundamental equations or laws of physics. These must be precisely adjusted for life to occur. And I'm going to give an example here. That should be M1, that's overlapping there. Here's Newton's law of gravity. This says that the force between any two masses, M1 and M2, like myself and the center of the Earth, is given by the gravitational constant times the one mass, me, my body, times the mass of the Earth, divided by the distance between me and the center of gravity of the Earth squared. That gives me the force. So if I wanted to calculate my force, which is what is measured on a bathroom scale, like in pounds is a measurement of force, not of mass. I'm about 77 kilograms, and I've weighed that for almost all my life, about the same. I hardly ever vary, no matter what I eat. So if I eat too much food, I just get really hot or hyperactive and have to go running or something. So my body immediately burns it off. So if I wanted to calculate, I'd take G, which is this number here, multiply it by my mass times the center of the mass of the Earth divided by the distance between them squared. Now, I'm Dr. Collins, so let me give you just a piece of medical advice here. If you want to lose weight, which is the force on a bathroom scale, you need to try change M1. Don't try changing G. That's just too difficult. Okay, so that's the only piece of medical advice I'll give here. Okay. So how fine-tuned is the strength of gravity? The answer, we must look at the range of force strengths in nature. And so here's the range of force strengths. And one way of thinking about this, you can do what's called a dimensionless measure of them, but another intuitive way of thinking about them is take two protons and a nucleus. Among those two protons, there'll be the strong nuclear force will be between them. There'll be electromagnetic force, they'll be repelling each other. There'll be what is called this weak force, which is another kind of force. And there'll also be a teeny gravitational attraction between them. If you looked at the gravitational attraction between them compared with the strong force would be approximately 10 to the 40th power stronger. And that's the G, and that's given by that number. G naught is the value of gravity in our universe, that constant you saw on the previous slide. The strong nuclear force constant is about 10 to the 40th power stronger. That's 10 billion, thousand billion, 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 billion times the strength of gravity. So that's a huge range of strengths. And so you could represent this range on a scale. If you had a scale across the universe, the gravity would be in the first 1 trillionth of an inch, and the strong nuclear force would be 15 billion light years away, which is a huge distance. Light travels 186,000 miles a second. there's about 86,000 seconds in a day. There's 365 and a fourth days in a year. Multiply those out and then multiply by 15 billion. That's how far across the universe is. And so gravity is just way down here. It's just in a teeny area on the scale. So that gives you a kind of idea of this range of force strengths. Now you can do some thought experiments. Let's suppose we increase the strength of gravity by 1 part in 10 to the 34th. That's 10 to the 34th is 1 followed by 34 zeros. This is scientific notation. That's what I used before. 10 to the 40th, 1 followed by 40 zeros of the range of force strengths. So that would constitute a billion-fold increase. That might seem like a lot, but it's nothing compared to the range of force strengths. It wouldn't even bring gravity up to the first inch on that ruler. In that case, even single-celled organisms would be crushed on a planet that is our size. I mean, the force of gravity would be so incredibly strong. And so to get a force of gravity that was all reasonable that could allow our kind of brain size, you'd have to shrink the size of the planet to around 100 feet in diameter. And in that case, you couldn't support an ecosystem. So that's one thought experiment you can do. So if in a strong gravity world, all life would be crushed. You couldn't have actually you have either the choice between being completely crushed or no ecosystem that could support our level of intelligence. But it's actually worse than that. And then I go to another slide. In fact, as you increase G, you can't increase the size or decrease the size of the planet fast enough to retain an atmosphere and keep the force on the planet the same. So you have what you have to do to keep an atmosphere like oxygen, you end up being forced into increasing the force on a planet. So if you increased G by a mere 64-fold, this is nothing like the billion-fold, the force of gravity would have to be 4 times as large. A 400-fold increase in G would result in any such planet having a surface force at least 10 times as large. Such a planet would be far less ideal for embodied conscious agents, particularly for doing science. So you already see a little bit of the fine-tuning for scientific discovery already in place here. And then a significant decrease in G would also have serious negative effects on life. So what you have, the strength of gravity not only must be within an exceedingly narrow range of values compared to the total range of force strengths for life to occur, but it must be in an even narrower range for it to be optimal for beings like us, particularly optimal for doing science. So you're already seeing hints there of the fine-tuning for scientific discovery, which I said I wasn't going to talk about a lot in this talk. I can if people ask me questions about it. So if you want to give a radio dial analogy, now you don't see these around very much unless a person's a collector of antiques. You know, it's all digital now. But I grew up with this, where you had to tune the radio in, you move this dial around. And I grew up out west where all the radio stations were called K. And back east, they're WK. So in this terms of this radio dial analogy, you would have to tune your dial, if you thought of gravity there, to within just a teeny range, 1/1000th of an inch of this dial that's stretching entirely across the universe. That 1/1000th of an inch would be the one that would be a fine-tuning of 1 part in a billion-fold increase in gravity. So it'd have to be just this teeny little region here you'd have to tune it into. And if you wanted it optimal, it'd have to be within an even millionth size of that region, even much smaller. So you can kind of give an analogy that's fine tuning. Now, here's another example of the fine tuning of a constant. This is the one that's most discussed in the physics literature. It is called the cosmological constant. The standard theory of the cosmos, called the Big Bang theory, is that the universe started from an initial very, very hot but visible universe that we see. Everything you see, those 300 billion galaxies, was condensed into a region less than the size of basketball. Very, very hot, very, very dense, because you had all that matter was in that region. And then it expanded outward. And the rate of expansion is influenced by what's called the cosmological constant. As it expanded outward, pretty soon the matter cooled down and there's slight ripples in the matter was mostly uniform with slight ripples. Those slight ripples gave rise to galaxies. Then when galaxies formed, they gave rise to stars within the galaxies. And some of those stars were called supernovas, which produce the higher elements we need for life. And then fortunately, supernovas are such that they blow up. So once they produce the elements within the star, they blew up and got it scattered into space. And then you got planets like Earth eventually, and what's called second generation stars. So that's just a really brief story of how the elements got here on Earth. But the point here is, if the universe expanded much more rapidly than it did, there wouldn't be enough time. It would have expanded too rapidly for those ripples. They'd been stretched out and they couldn't condense into galaxies. So there wouldn't be any galaxies, and hence no planets and no life. On the other hand, if the cosmological constant was too small, particularly that it can go both negative or positive. If it was negative, the universe would have collapsed too rapidly, because it serves the cosmological constant either serves as a repulsive force if it's positive, or as attractive force if negative. The universe would have collapsed too quickly for galaxies to form, and hence there would be no life. So how fine-tuned must it be? Well, the typical estimate in the physics literature is a whopping 1 part in 10 to the 120th power. That is 1 followed by 120 zeros of its theoretically natural range of values. This is unimaginably precise degree of fine-tuning. So there I've given 2 constants that need to be fine-tuned. And so here I have the diagram of these. You hear me okay still? Thumbs up. Everyone, thumbs up if you're hearing me. Are we frozen out? Hello? Katie, did we freeze? Katie? Did you
Yes,
come?
we can hear you. Yes.
Okay, how far did you get with what I was saying?
It only cut out for a little bit, so I think you're good.
1 part, the cosmological constant tuning is where you're
Okay,
at.
where I cut out. Okay. Let me go back to that. So let me just go back to that one. So it had to be 1 part in 120th power, 1 followed by 120 zeros. And this is unimaginably precise degree of fine tuning. So if you did the radio analogy, it would be much, much less than a trillionth of an inch in this little region that you'd have to fine tune it within. over this ruler that stretched plus 15 billion light years in one direction and 15 billion light years in another direction. So an enormous amount of fine tuning. So many of the constants have to be fine tuned in a really precise way in order for life to exist. And so this is widely recognized, for example, by the late Stephen Hawking at Cambridge University. He says they have to be very finely adjusted to make possible the development of life. Dennis Guillemot, former director of Cambridge University Observatory, says the same thing. It must be changed the concepts a little bit. It is very likely that intelligent life would not have been able to develop. So that's the fine tuning of constant. And I've given you just 2 examples or several other examples you could give. Then quite a few other examples, actually. Then there is the most fine-tuned of them all. And that's the initial distribution of mass energy. That is at the time of the Big Bang. Remember, I talked about the universe being the size of, less than the size of a basketball. Can people hear me okay? Katie, can you hear me? Okay. So when I say initial distribution has to be fine-tuned, it means it must have to be just right. It might look from one perspective as uniform, but it really isn't. It has to be just precisely in the right structure. Just like if you looked at a zygote being the cell fertilized egg that gives rise to, for example, a human being, it would just look like a blob of protoplasm. But as a matter of fact, it has to be enormously structured in precisely the right way to produce a human body or any other kind of animal body. So how fine-tuned must the initial distribution of mass energy have to be? But here you can ask Roger Penrose, who's one of Britain's leading theoretical physicists and cosmologists. And it's actually a pretty simple calculation to get this result. And he uses this, I don't know if he believes, I don't think he actually does believe in God, but he uses this idea of the creator God to illustrate his point. In order to produce a universe resembling the one in which we live, says Penrose, the creator would have had to aim for an absurdly teeny volume of phase space of possible universes. What is phase space? That's the physicist way of measuring the number of possibilities. For example, the phase space of, when you flip a coin, it's heads or tails. It could come up. The phase space of that is heads or tails. The phase space of flipping 2 coins is tails, 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 heads, heads, tails, and heads, heads. Those are the set of possibilities. So phase space is a set of possible configurations of mass energy. And he says it would have to be 1 part in 10 to the 10 to the 123rd power. 10 is being raised to 10 to the 123rd power here. So it's 1 followed by 10 to the 123rd zeros. It's just an enormously small number, unimaginable. So I got this from somebody else, how to try to even imagine it. So let's suppose God gave you a photocopying machine and unlimited supply of papers, and you just photocopied to your heart's content, just kept photocopying papers with 0, 0, zeros. And pretty soon it was so fast, it filled up the entire visible universe. It's all that space out there. And then you put a 1 in front of all those zeros. The number you got with the 1 in front of those would be not as large or smaller than this number here. So that's how huge this number is. It's just enormous. So the initial distribution of mass energy must fall within an exceedingly narrow range of values for complex life to occur. So recap the kind of fine-tuning. We have fine-tuning of laws of physics, fine-tuning of the constants of physics, and fine-tuning of the initial conditions of the universe. And I'd mentioned they also see precisely adjusted. So living conditions would be optimal within our law structure, and it would be optimal to develop technology and discover the universe. That's referring to the constants of physics. They have this additional optimality, it seems. So here's years ago when I first started thinking about this, way back in 1994, a student of mine gave this analogy. The dials, I used dials for these constant. They had to be perfectly set. Life can exist. If the dial's imperfectly set, no life. And this is, there's what they call a cumulative case argument for fine tuning. This is why the evidence is so strong. It's many lines of evidence pointing in the same direction. The laws of physics, if you look at those, the constants of physics, and if you look at the initial conditions of the universe. So even if you found a mistake in one of them, you would still have very convincing evidence because there's all these independent lines of evidence for the fine tuning. So it makes it extremely strong. It's like in a court case finding that the DNA evidence that the defendant is guilty, fingerprint evidence that the defendant is guilty, motive that the defendant is guilty, and other people's testimony that they saw the defendant do it. If you had that kind of evidence, you would have it'd be beyond a reasonable doubt. So thumbs up if you can, I'm still there, you can hear me, okay. So for many people, the fine tuning immediately suggests divine creation as the explanation. This is true for theists and non-theists. Even though non-theists may reject it, they recognize the appearance of divine creation. So non-theist theoretical physicist and popular science writer Paul Davy says, not only the fine-tuning evidence, but the other evidence, the impression of design of the universe is overwhelming. And Sir Fred Hoyle, also another non-theist, he says a common sense interpretation of the facts suggests that a super intellect is monkey with physics, and there are no blind forces in nature. So what alternative do non-theists offer to divine creation? So there's two major alternatives. The first alternative is the lucky accident brute fact hypothesis. Our existence is an extraordinarily lucky accident. Now, accidents happen all the time that are very, very improbable. If you flip a coin 100 times in a row, whatever sequence it comes on is enormously improbable, about 1 part in 10 to the 30th power, which is really, really small number. However, if it comes up in a special, it's when it not only is really improbable, but comes up in some special configuration that is meaningful to us. That's when we want to infer, which we don't accept the chance hypothesis. So here is an example of an extraordinarily lucky ink spill, or if I'm talking to college students and you're like living in your own apartments, your roommate might leave, food in the back of the refrigerator and it might mold. So if you found a mold like this, and this is the way the mold looked, you would not ascribe that to chance. You would think your roommate, for example, was a biology major, actually had designed the little microbes and fungi to come up, mold to come up in this pattern. You wouldn't accept it as just having by chance. Why? Because there's something special about it, and it's just far too improbable. Likewise, for many people with the fine-tuning of the universe, it seems enormously improbable and something special. Hey, it gives rise to beings like us. So the second alternative non-theistic hypothesis is called the multiverse hypothesis. According to this, there are an enormous number of universes with different initial conditions, values for the constants of physics, and even the laws of nature. Thus, simply by chance, some universe will have a winning combination for life. Supposedly, this explains why a life-permitting universe exists. So humans are winners of the cosmic lottery. If you have enough universes, just like if you have enough lottery tickets, eventually somebody's going to win. So there's been a lot of well-known advocates of the multiverse hypothesis. Here's two of these I've met in person and talked to. Max Tegmark, Massachusetts Institute of Technology, Sir Martin Rees, former Astronomer Royal of Great Britain, and cosmologist, I haven't ever met him, cosmologist Stephen Hawking, Cambridge University, who's now deceased. So in recent books, there's been recent books on it. The many worlds in one hypothesis, the cosmic landscape universe, multiverse. I have an article in this one that says even if the multiverse is true, you would still need some form of design. And then there's a more recent book by Stephen Hawking and Leonard Madel now on the grand design, which advocates the multiverse. Now, I just say something about this book. This shows where physicists could get extremely arrogant and think they know everything because they know cosmology. So one of the most egregious worst things this book says is that at the very end, repeats this several times, that we can now explain how the universe exists to begin with. We don't need God anymore, because it says but the universe created itself out of nothing, and these seems like they mean really nothing there, via gravity. And my first thought there is not even God can pull that trick off of creating oneself out of nothing, because you have to exist before you can do anything. And then earlier on in the book, around page 7, it says that we don't need philosophers anymore because they haven't kept up with cosmology, and as though cosmology could give us ethics. And then goes on to say that recently human beings, recently we have found that things, people used to believe things were as they appeared to be, but recently physicists have discovered with quantum mechanics that that's not the case. And I'm going, what? Think about what you said for a minute. For most of human history, people did not believe things were as they appeared to be. They believed there's angels and demons causing things, so they weren't as they appeared to be. They believe there's a whole unseen realm. All the major world religions, and Copernicus, who hundreds and hundreds of years ago in the 1400s advocated the idea that the sun is at the center of the solar system, advocated something against what appears to be the case. What appears to be the case is the sun goes around the earth, not that the earth is rotating. So it was sometimes, I think, the arrogance, they don't even really think very carefully about what they say. I just say stuff, and I'd never do that when writing. I always think about, well, it's just, how would this be critiqued? Anyhow, that's a side note, but it shows a lot of the arrogance of some of these cosmologists. Sometimes they're popular writers. They also often get the history of science and religion wrong with this conflict thesis. And so stuff that's been historically debunked, but I could go on about that. I just say that really briefly. Okay, so back to the multiverse hypothesis. It comes in two major versions. So one is what's called a purely metaphysical version. So the late Princeton University philosopher David Lewis advocated this, and cosmologist Max Tegmark. And they say every possible universe exists. So if you like Lord of the Rings, there's a universe in which you could meet Gandalf. That's if it, long as it's a consistent reality that exists. If there is, you like Rings of Power, the new Amazon one that's on, which I like, you can meet Gladriel in that. There's a universe there. Now you can't get to these other universes. That's the only hitch in all this. So they exist somewhere. So every possible reality exists. So of course there's going to be one in which life exists, namely ours. Now this is not widely advocated. It runs into, it seems first of all incredible, and it runs to other problems. So the one that's widely advocated among those who are advocates of the multiverse hypothesis is what I call the universe generator hypothesis. And that is there's some physical process, and this is my cartoon image of it, that generates universes. So here's the universe machine generating universes and puts it on a conveyor belt. So, sorry, okay. So the one that's commonly advocated is a mix of inflationary cosmology, which is a highly speculative theory, and superstring theory, which is also speculative. There's no evidence for either one of them right now. But the idea is that there's kind of pre-space you could think of, and it's rapidly expanding very, very rapidly. And as it expands, it produces these bubble universes like an ocean full of, ivory detergent, producing bubble universes, and expands so rapidly that universes don't collide with each other. And every time the universe is produced, at least some lower level laws and the constants are adjusted at random. So eventually you will get a universe in which the constants are adjusted just right so that life can exist. Can you still hear me okay? Okay. So what are possible theistic responses to this? So some have, it takes more faith to believe in this than to believe in God. Where did the universe generator come from? That goes back to the cosmological argument. And the one I'm going to focus on here is the universe generator itself would need to be well constructed to produce even a single life-sustaining universe. So it pushes the problem back one step. It doesn't really get rid of the problem. There's also another one that's much discussed. It results in what's called Boltzmann brains, which are just observers that exist for super brief periods of time and then they vanish. And we would expect ourselves to be one of those if that hypothesis were true. And it doesn't explain the optimal universe for science and technology. So I'll focus on number 3, that it cooks the problem of design back one level. So here's an analogy. I used to have a bread machine and is now just being used as a planter because the program quit working right. But when it was working, it had to have just the right ingredients and just the right program to produce even one decent loaf of bread. And often I would forget something. I'd be thinking about something else and forget to put the yeast or gluten or water in, and the bread would turn out like hockey puck. It would be something you could use for hockey, but not really eat very well. So in order for the even a bread machine to work properly, it has to be well constructed, right ingredients. In analogy to a bread machine, it seems like a mini universe generator must just have the right laws and have the right ingredients, initial conditions to produce life-sustaining universe. In other words, it has to be well built. Actually, that's a registered trademark. So if you get a like you buy an item from this company, well built, it's going to work because look at the name. Okay, it's a joke. So a bread machine analogy is verified by inflationary superstring theory. If you look at the scenario most commonly advocated for this generator, which I did in that article I had mentioned I had in that book on universe or multiverse, you find it has to have just the right set of laws and special mechanisms to produce even one life-sustaining universe. So the conclusion is the multiverse hypothesis still just kicks fine-tuning back one level. Who designed the machine? Basically, the physical process produced the multiple universes. So the universe generator hypothesis does not significantly undercut the fine-tuning argument. Theism is compatible with the universe generator hypothesis. That's the conclusion there. And then the overall summary is there's 3 responses to the fine-tuning evidence: theism, multiverse hypothesis, brute fact hypothesis. Many people's mind, this is just unbelievable. This just kicks the problem back one level. And so you're left with theism as the best explanation, because multiverse requires design. And if you want further information on this, there's online, The Great Debate. And I debated with an atheist on this issue. You could just look me up there. And I'm going to take questions now, but I do want to cover at some point this issue because it's so important, the who designed God objection. So I'll take questions now from people in the audience.
Awesome. Thank you so much, Dr. Collins.
I'll start. So what kind of response do you get? Obviously, you participate in debates. I know that this talk has been given at Cambridge. I'm sure you've given it lots of other places. And obviously, you're in the case for a creator. So you've had many opportunities to talk to many people from many different backgrounds about this. What has the response been?
The response, I mean, the biggest response I get is the who designed God objection. Atheists, often a skeptics club will come, and they get this from Richard Dawkins, who's very popular new atheist. And this is really his sole objection to a design argument and belief in God. This is his main one. And they think they're just going to nail me with this objection. And so I should probably just go through that you've asked that question, this response, and see what's wrong with it, or this question. So here's the objection. So who designed God? So here's, it's in the book, Atheism, the Case Against God. Here's the one way it's put. If the universe is wonderfully designed, Smith says, surely God is even more wonderfully designed. He must therefore have a designer even more wonderful than he is. If God did not require a designer, then there is no reason why such a relatively less wonderful thing as a universe needed one. So other authors, this is one way of putting it, invoke the principle that the designer of an artifact must be at least as complex and in need of explanation as the artifact itself. So the idea is, by invoking God, you've just pushed the question back one level. And so if you're going to accept God as the quote ultimate brute fact, aren't you just better off if, pushing it back to God, something has to, you have to accept, explanation has to stop somewhere. You're actually better off just accepting the universe. It stops with the universe. So that's how the objection goes. And to look at the objection, we have to look at why something needs fine tuning. So why does this picture, why is there fine tuning needed? We don't think there's fine tuning needed here, but not here. Okay, well, it has this ink blotch here, has all these small little dots. And so they have to be arranged in just the right way to make a meaningful pattern. where the overwhelming majority of arrangements of ink spots and white areas do not result in a meaningful pattern. Okay, so the issue of fine tuning is, why is a universe just the one that results in this meaningful pattern when there's all these other possibilities seemingly at an equal level that don't? So if you had an anthropomorphic concept of God, God was a, which like the Mormon church has, if God had a physical brain or even a finite mind, then the same fine tuning problem would confront the existence of God's brain or mind. The matter composing God's brain would have to be organized in just the right way for God to think. And I think this is what's in the back of a lot of these skeptics' mind. They haven't really understood the classical conception of God. So they're still thinking of God as this kind of being with some kind of brain or something out there, that they think that's what Christians think. And so if that's the case, you would have this problem. But the classical theism is not anthropomorphic in this way. Both in East and West, God is conceived as infinite and unbounded and has little or no internal complexity. It's not like God has parts, not even property parts that have to be arranged. So without internal complexity, there is no need to be designed or fine-tuned. So it's what they call a red herring. It's an objection that just basically misunderstands what the idea of God is that's been held throughout history. It has always been held that God is not composed of parts. So there's nothing to fine-tune. And because God is infinite and thus unbounded, there are no complex laws that might require fine-tuning in order to determine the extent of God's powers. If God was a finite being, then there'd have to be a set of laws that could determine, for example, that God could create unicorns, but not centaurs. Would have to determine the extent of God's powers. So the real issue, then, what is the real issue? It's whether it's more plausible to think there's this infinite and unbounded being. So you might have some kind of philosophical difficulty because believing in this involves some kind of infinities, unboundedness, which, by the way, are essential to modern reconstructions of mathematics anyhow. So I don't see a problem with infinities, but it's which is more plausible, a being that such a being like this could be the ultimate explanation of things, or that, for example, this is all just a lucky accident. So that's what the issue comes down to. It's not the issue of whether God needs design or not. Okay, and so I have some more I could say about that. So that is the most common objection I get. Now, in the Cambridge one, I got other objections about, oh, how can you talk about probability? Because doesn't probability require that there be a reference class of universes? Well, and then there's good reason to think it doesn't, not the kind of probability we're talking about here. And so if you want me to look at those, if you're thinking of those sort of objections that philosophers might raise, you can look at that link I sent for the Cambridge Philosophy Club talk. It went on for like the question and answer went on for 2 or 3 hours. So,
Wow.
Hi, Dr. Collins. My name is Grace. I am actually not in the field of science. I'm a teacher. I teach elementary students, but I was just curious. I learned so much about from your presentation, but were you a Christian before you started studying science? Or?
I hardly can hear you. Could you maybe speak more into the microphone?
Walk up to the.
Hi, Dr. Collins.
Yes.
My name is Grace Choi. I'm a teacher. I teach young children in an elementary school. I was just curious. I learned so much from your presentation. I really wanted to thank you. But have you, were you a believer before you started entering the field of science, or did science push you to believe in God more?
Okay, so I was a believer before, I discovered the fine tuning, but I didn't have a high level of certainty that God existed. It was sort of an issue I struggled with. Since my study of science, I have actually become, not just with fine tuning, there's much more going on than just that. I am just convinced, I don't see how you could do without either theism or something close to it. So I'm actually writing an article now for a book called Christianity Contested. It's an anthology. It's coming out with a significant publisher and intended to be for kind of college level audience, and pretty much goes through the reasons why I think the science is highly, strongly supportive of belief in God and is compatible with Christianity. And the success of science is just the opposite of what you often hear, that it undercuts belief in God. Rather, it strongly supports God. So the additional, just the bare order of the universe to begin with, but the tremendous, another case is just a tremendous success of mathematics. And many people have commented on this beautiful, elegant mathematics in finding the basic laws. Albert Einstein was, he said the most miraculous thing about the universe is it's intelligible. Eugene Wigner, the founder of quantum mechanics, said, one of the major founders, said the unreasonable success of mathematics and the physical sciences is a miracle which we neither deserve nor asked for. And it's really hard to explain how that could have happened by chance, but is compatible with a God which was believed all the way up, was motivation for a lot of what happened in science to Newton, Galileo, and goes way back to Plato, actually, who wasn't a theist. He had a sort of theistic conception that God created the world according to a mathematical pattern. And that has been just hugely confirmed. And the math is far beyond, it's not just ordinary math that you would, you maybe think the kind of everyday mathematics like numbers. The really impressive is these really abstract but highly fruitful, beautiful systems like complex numbers, which are central to quantum mechanics, which is the most precise theory we've ever had. And both theist and atheist physicists have commented on this, how scientists develop beautiful mathematicians develop beautiful mathematics for reasons that have nothing to do with physics, and then they turn out to be enormously useful. And then I've extended that to the case of actually, this is which I got a major outside grant for, fine tuning for scientific discovery. I looked at what happens when you change one of those constants of physics, like the gravitational constant, and change its value a little bit. What happens to our ability to discover the universe? And what I found is that it gets worse. Basically, and that gave rise to a thesis that constants are actually optimal for scientific discovery. And that eventually led me to get the most solid cases I could, that this fine tuning for discovery is over and above that for life. So it can't be explained by a multiverse. I went into particle physics, which took me quite a bit of time to work through, but it all worked out. So that I'm trying to finish, and for the publication of all that work. And I'll be delivering that, a one-day workshop I'll be delivering at in front of physicists and philosophers at Rutgers next summer, Rutgers University. So, and then hopefully get the book out the next year. So that has been very convincing to me. And I mean, there's so many lines of pieces of evidence along these ways, like the example, and this is very accessible, the conflict thesis, that the science has been in conflict with religion. And that thesis was promoted. There was two books, one by Anderson Dixon White, who was president of Cornell University, that promoted that, and was horribly bad history. The footnotes, people that looked up the footnotes, they didn't go anywhere. Were just made up. And then I forgot the name of the other author. So 2 big books on that. And then their misrepresentations have been repeated again and again by like popular science writers and others who don't. The popular science writers should know better, but they still repeat them. And about for 30 years, historians of science, I mean, this is almost unanimous among historians of science, that this thesis is just false. Like you look at Galileo, how it was supposedly because of religion. Well, a lot of the reason, the Pope at that time was an actual supporter of Galileo, but Galileo was a pretty arrogant person. And so when the Pope, for political reasons, didn't want to, things were unstable at that time, didn't want him promoting that he had proof for this idea that the sun was at the center instead of the earth being at the center. And he didn't have proof. But then he wrote this book called The Two World Systems, and the person he called Simplicito, which is the simpleton, mouthed everything the Pope said. So what he was doing is making fun of the Pope. Well, obviously that was politically stupid. So that was a lot of was behind it. They say like Christians, were the ones that destroyed the Library of Alexandria. There's absolutely no evidence for it. It was just made up. And so you can get a good place to look just to get started of this is a podcast on that with Unbelievable. It's a series out of England, and he interviews both 2 theists and an atheist historian of science. But it's been I know it's been known for like 30 years, so that's just another whole factor. So I could go on and on about the various reasons I have for why the whole materialism that goes on cannot really make sense of the mind and our capacities for reason. So which is central to science. So mathematics is central to science. There's fine tuning for discovery. There's all this different things that just don't fit with their framework, and they really don't have any evidence for it. It's just really a faith commitment they have, that the world is just this material reality. So I guess that's the big picture for me, is just strongly in favor of theism. And I'll say one more thing about that. It's and my study of quantum mechanics too. I mean, this has been for like 30 years. I plan on writing, which I've been working on in conjunction when I teach philosophy of science, quantum mechanics and God, and how I think quantum mechanics is also very supportive of the theistic view, particularly the Christian theism, that the world is upheld by the word of God, which I take as the structuring principle behind the world. So when I look out at the world now, I see it, when I just see it as being as a miracle that it works at all. And that has kind of opened me up to religious experiences. Often I have a jogger and I stay up late at night. So I often jog where I live. I can jog through these areas and at night. And I do have the experience of God being there, really upholding the world, that there's something much more going on, because it's entirely a miracle to me that it works at all. And so I think Christians would benefit a lot if they started seeing, I do think God does special miracles. I don't see any problem with that in science. I mean, I'd see a problem if God didn't do it. So because if God created the whole system and sustains the whole system, God can sustain it slightly differently and a miracle will occur. But I think that we look for too much, we want that miracle, that exception to the laws of nature, when what we should be seeing is that the laws of nature themselves, the fact that you have a solid table that you're setting down somewhere, that in so many different ways, it's all a miracle. That's a continual miracle that you continue to exist at all. And when you have that sense, you don't fall into this kind of science as opposed to religion idea, which is very harmful. You don't need to be seeing, miracles happening places, spiritual miracles happening places they don't happen, so on and so forth. So I hope that kind of elaborate a little bit on your question. Anyone else?
Thank you so much, Dr. Collins.
I should say can I say one more thing in connection with that, is that there's also this, I heard one of these podcasts, and he was somebody going into cosmology, a smart guy, but he said he kind of gave up faith because science could explain the world. He didn't need God anymore, which is this other false conception that you see God in the exceptions to the world, like the miracles, when that's a kind of God of the gaps, what they call God of the gaps conception. Where God is most manifest is in the fact that the world works according to these precise mathematical rules, that it is this ordered whole that is extremely fine-tuned, and the very success of science, so it's just got it reversed. It's the very success of science, that the fact that it was structured intelligently, that we could understand it in a way that we could unravel its underlying mathematical structure. That's what is the most demonstrative of God. It's not seeing some exceptions, things that we now can't explain, but we would expect science to explain someday. It's like somebody, the clock, old style clock. The science can tell you how the gears work and how all the gears and everything give you the hands to move. That's the job of science. But that's not, when you asking why is there a clock at all, the little beings there talking about gears and the laws that they obey is not going to give you an answer to that question. There you need to go outside of science. So you ask, why is the universe this special way? You need something beyond science. So there is no conflict at all. It's rather that science, the more science has really shown it can explain, the more support that is for theism. All right.
Thank you so much, Dr. Collins. We do
Yeah.
have a gift for you. It is I don't know if you can read it, but it
Says
says
the creation of
the creation of the world, God's invisible qualities have been clearly seen, being understood from what has been made.
Yeah, that's very fits into what I said at the beginning, because it's the vastness of the cosmos and its age does not take away from God, but actually shows who God is in a finite way. And that is there's a whole nother thing of people thinking the discovery of the universe had a beginning somehow. And then kind of certain interpretation of Genesis 1, which I think is faulty to begin with. But that was presented a problem for atheists, not for theists, because atheists were much more comfortable with an eternal universe. So when it was first proposed that it had a beginning, which, by the way, the Big Bang Theory was proposed by a Belgian priest called Lemaitre. He was the first one to propose it in the late 20s. Though Hubble gets a lot of the credit because Hubble went out there in the public trying to take credit for everything. So it was called the primeval atom theory. And so really that was proposed by a Christian. And then it presented problems for atheists because it fits so nicely with the idea that Christians have always held that the universe had a beginning.
Yeah. Well, we would love to be able to send that to you. So if you could email me your address, and we'll get that right to you.
Okay, all right, thanks. All right,
Thank you.
okay.
So much, Dr. Collins.
All right, I'll sign off here.
All right.
I'll come back to earth here from my
Have a good rest of your
transport
Sunday.
myself back. All right, bye.
Bye.
Thank you.
All right.